All right, so remember we talked about this in class that if we have two numbers, well, which number is greater than? Well, 10 is greater than 6. If I add the same number to both of these, which if we're solving an equation and we're doing our inverse operations, we're doing it to the same thing to both sides. So that's what we're essentially doing here. So now 6 plus 2 is 8, 10 plus 2 is 12. So here, the value that was greater when we're adding the same thing is greater at the end as well. And that should make sense because we're increasing both sides by the same thing. And if we're increasing both sides by the same thing, then the one that was greater to begin with has to be the greater to end with as well. Same thing for here, 10 is still greater than 6. If I'm now subtracting the same number from both sides, like I'm using my inverse operations, let's say if it was x plus 2 and now I'm subtracting both sides, well, the number that was greater to begin with, once again, is going to be the number that is greater to end with because we're decreasing both by the exact same thing. When we multiplied, so 6 and 2. So if I had x over 2, so now if we're solving our inverse operations to now multiply here, same thing. If I'm multiplying, well, 6 times 2 is 12. 10 times 2 is 20. So if we're multiplying by a positive number, well, then that value is going to remain greater than as well. So nothing's changed in that relationship. And now if I had 2x, and I'm dividing each side by 2, same thing. Here, I'm starting with 10 is greater than 6. If I'm dividing both by a positive 2, we know that our relationship isn't going to change because we're decreasing each thing by the same value as well. And it's positive, so it's going to remain at the same number. So when we're dealing with just regular addition or subtraction, nothing changes. When we're dealing with division or multiplying, as long as if that number is positive, nothing changes as well. So let's just go through some of the examples that we showed in class where we do have to think about this and things do change. So one of the things that we just had to discuss and we talked about was on the positive side of the number line, well, 10's the quote unquote, the absolute value is bigger than the absolute value of 6. And when we look at that, we know that 10 is greater than 6. But on the negative side of our number line, the number that is quote unquote smaller, so if we take the absolute value of -6 and the absolute value of -10, that 6 is, we would think, is smaller than 10. Just when we look at those numbers, it's actually greater than because it's closer to 0. So you see our relationships change as we move from one side of the number line to the other. So if our question was -2x and we're trying to solve for this, so we know -6 is greater than -10. If I divide each side by -2 now, so I'm dividing each side by -2, I'm going from this side of the number line to the other side of the number line. So now it's going to give me positive 12 and positive 20. And since I'm jumping to the other side of the number line, I know that now the relationships change. What was once greater than is now going to be less than because the quote unquote bigger number that was closer to 0 on the negative side is greater because it's less negatives, but now on the positive side, it's less than. So we have to make sure that we flip or change that inequality. Here, -6 is greater than -10. Well, if I'm multiplying each side by -2, once again, I'm going to the other side of the number line. So now my answer becomes 12 and 20, and we need to make sure that we flip that inequality. What was once greater now is less than. All right, so now when we're dealing with inequalities, because we're dealing with the range of answers and not just a singular one like we did with equations, we're saying this is a set of numbers that are greater than or less than. And since we're moving the other sides of the number line, we need to make sure that we're taking into consideration that the numbers that were larger on the negative side, well, when we go to the other side of the number line, they now become less than. All right, so let's go ahead and just solve a couple questions. So we're saying what numbers of 3x plus 4 is less than or equal to 19. So we will need to solve and then graph. So the first thing we need to do is isolate that variable. So we'll subtract 4 from both sides. So it's exactly like the equation. So 3x is less than or equal to 15. We now divide by 3. So x is less than or equal to 5. So that's our answer algebraically, and you will need to be able to graph this as well. So the way that I'll have you do it is we're going to make 5 tick marks. The answer that we have that we isolate, just put right in the middle, and then just pick any numbers that are greater than or less than. So when you do it, those make sure we keep the same pattern. Since I add it by 1 every time, I need to subtract by 1 on the left side every time as well. And remember, it is a closed circle. If it is just less than or greater than, it is an open circle or not solid, and that's telling us we don't include that number. And if it's less than an equal to or greater than or equal to, it is a solid circle or tongue as we include that. So we will have a solid circle at 5. And then we're looking for all the numbers that are less than. Well, 3 and 4 are less than 5, so those will be our answers. Remember, we can test and plug it in. And we can plug it back into the original, make sure we didn't make any mistakes. So 3 times 3 plus 4 is less than or equal to 19. Well, 3 times 3 is 9 plus 4 is 13. So that is less than or equal to 19. So we know that we picked the right answer. All right, so for this problem here, solve it just like you would an equation. Before we can graph, we need to isolate our inequality in this point. So that means we need to simplify it first. So we're going to multiply and distribute that 2 in. So it becomes 5 minus 2x minus 8 is less than or 17. Remember, we only flip our inequality when we're multiplying both sides by the same number. So when we're undoing our problem and doing our inverse. If we're just simplifying one side of that inequality, we're not reversing it because that 17 is not changing anything with it. And now we're going to combine our like terms of 5 minus 8. So it's negative 2x minus 3 is less than 17. We'll now add 3 to both sides. So now we have negative 2x is less than 20. And now to solve, we will divide each side by negative 2. I'm going to write the answer up here. So that then, now that we're dividing each side by that negative number, I need to flip it. So x is greater than negative 10. So now I'm going to draw my number line. I'm going to make my 5 tick marks. I'll put negative 10 right in the middle. I'm going to add 1 each side. I'm going to subtract 1. This is now going to be a not solid or an open circle. It's greater than. So this is now telling me I'm going to the right because all my values on the number line are greater than or to the right. All right.